In this video, we are going to look at explicit form, which is one of several ways that we can represent an arithmetic sequence. Now, as a reminder, an arithmetic sequence is an ordered list of numbers that is increasing or decreasing by the same amount at each step. So I've written out an arithmetic sequence here, 3, 7, 11, 15, 19, etc. This is one way we can represent an arithmetic sequence, but there are many ways. One of those ways is explicit form. So let me work through the pieces that make up this arithmetic sequence, and then we'll see how we can represent it in explicit form. So the first thing that we want to look at is, what is our starting value for our arithmetic sequence? Our starting value here is 3, and so I'm going to write that out. We have a starting value of 3. The next thing that we want to look at is what our common difference is. In other words, what are we adding or subtracting at each step to get the next number in the sequence? So to go from 3 to 7, I'm going to add 4. In order to get from 7 to 11, I need to add 4. And so on and so forth. We have the same difference between each two numbers. So plus 4 at each step. And again, that is our common difference. We have a common difference of 4. Okay, now each of these positions, we can give it a name. We're going to say that this is position A sub 1. This is position A sub 2, and so on and so forth. A sub 3, A sub 4, and A sub 5. Now we could call this sequence A, and this is just A at the first position, second position, third position, fourth position, etc. These are just names for each number in the sequence. Now let's say we wanted to find out what A sub 10 was equal to. That should be a question mark. In other words, what is the 10th number in this sequence? Well, we can reason our way through what this would be equal to. So let me write this out again. We have A sub 10. We're trying to figure out what the 10th number in this sequence would be equal to. Now, as with all of these sequences, or each step here, we start with 3. And then at each step, we add 4. And so if we knew how many times we needed to add 4, then we could come up with a formula for this sequence. So I have 3, and then plus 4. And then if I wanted to know what the second number in the sequence was, well, I'd only be adding 4 one time. And if I wanted to know what the third number was in the sequence, well, for that, I'd be adding 4 two times. 3 plus 4 makes 7, and then plus 4 again makes 11. And then similarly, if I wanted to know what the fourth step or what the fourth number in the sequence was, then I'd start with my starting value, and then I'd add 4 to get to 7, add 4 to get to 11, and add 4 again to get to 15. And so there's a pattern here. If I am looking at the fourth position, then I'm adding 4 3 times. If I'm looking at the fifth position, or if I want to find out what number is in the fifth position, then I'm adding 4 times. So whatever the position number is here, I'm adding my common difference 1 less than that. And so we can represent that like this. If I'm looking at the 10th position, then I'm going to be adding 4 1 fewer times than that. So 10 subtract 1. Just to reiterate that one more time, if I'm getting to the 10th step, then I'm adding 4 1 less than 10 times, or 9 times. So if we were to work that out, or simplify that, then we would have 3 plus 4 times 9. And then I can simplify 4 times 9 to 36. 3 plus 36 is 39. And so A sub 10, or in other words, the 10th number in this sequence, is equal to 39. So let's generalize this into a formula that will work with every sequence. And the notation that I'm going to use is A sub n. Actually, let me put that in purple. So I have a sub n, and remember n is just whatever position or step in the sequence that we want to know what it's equal to, and that is going to be equal to whatever our starting value is. So our starting value will always be a1, at least in this unit. Sometimes you will see you will see teachers or classes that start their counting at 0. So there's like step 0 and then step 1 and then step 2 and so on. But for our purposes, we're going to be starting at 1. And so our starting value will always be a1. And so let me write that here. It's going to be equal to a1 and then plus whatever our common difference is. So here our common difference was 4, and it's the same common difference here, and we'll label that d. So we have our common difference of d, and then we're multiplying that by whatever n is, subtract 1. n and subtract 1. And that's because in order to find out what I have at my second step, I'm adding my common difference once. In order to find out what I have at my third step, I'm adding my common difference twice. For the fourth step, it's 3 times, so on and so forth. It's always 1 less than whatever n is. And so I am going to put a fancy red box around that, because this is our general formula for explicit form. So I'll even put an arrow down there. This is explicit form right here. And so let's work out a few examples of using explicit form to describe an arithmetic sequence. So let's say that I have a sub n is equal to 4 plus 7 times n subtract 1. So I have an is equal to 4 plus 7 times n subtract 1. So the first thing that I want to do here is I want to identify what my starting value is and what my common difference is. So my starting value is 4 right here, and then my common difference is 7. So you'll notice that the 4 isn't multiplied by anything. That's a clue that this is your starting value. The 7 is going to be multiplied by n subtract 1. And so that's a clue that the 7 is our common difference. And so if I were to write out this sequence, then I would start with 4. I'd start with 4. And then I'm going to be adding 7 at each step. And so 4 plus 7 is equal to 11. And then 11 plus 7 is equal to 18. 18 plus 7 is equal to 25. And so on. And so again, we are adding 7 at each step. And so I'm going to, just to make this clear, what we're doing each time here, we're adding 7 in order to get to the next step in the sequence. If we wanted to find out what a sub 12 was equal to for this sequence, in other words, the 12th step in our sequence, then we could do it like this. So I'm going to write out a sub 12, because we're trying to find the 12th step in the sequence, and that's going to be equal to this right-hand side of the equation here, but we're going to substitute in 12 for n. And so we have 4 plus 7, and then again I'm substituting 12 in for n, so 12 subtract 1. And then I just simplify on the right-hand side. So we have 4 plus 7 times 12 subtract 1 is 11. And then I can simplify 7 times 11 to 77. And so the a sub 12 is equal to 4 plus 77 is 81. And so that's what a sub 12 is equal to, 81 here. Okay, let's work another one of these examples. Let's say that I have a sequence written in, again, in explicit form, and it's a sub n is equal to -3 subtract 4 times n subtract 1. So again, this is our formula or this is our sequence in explicit form. And the first thing we want to do is we want to identify our starting value. And so that's this first number here. It's the number that's not being multiplied by anything. And so I'm going to underline that in yellow. So that's our starting value. And then our common difference is the number that we're multiplying by what we have in the parentheses here, which is -4. And so to write out this sequence, so we have -3, and then I subtract 4 to get -7. And then I subtract -4 to get -11. And then I subtract -4 to get -15. And so on. Dot, dot, dot. This equation describes this arithmetic sequence, but what if I wanted to find out what the fifth term was, for example? Now, I could just subtract 4 again, as I've been doing. See, I'm subtracting 4 at each step here because -4 is our common difference. And I could subtract 4 again there. But let's actually work it out as an equation. So let's say that I'm looking for a sub 5, or the fifth step in this sequence, or the fifth number in this sequence. And so that would be -3. So I'm just taking this formula up here, or this equation up here, -3, subtract 4, and then I'm replacing n with 5. 5 subtract 1. And then I simplify what I have on the right-hand side here, so that's -3, subtract 4 times 5 subtract 1, which is 4. And then I have -3 subtract 4 times 4, so that's -3 subtract 16. And then -3 subtract 16 is equal to -19. So a sub 5 is equal to -19. And notice here that I was multiplying -4 by 4. And I'm also, in order to get to this step, you know, the fifth number in the sequence would be right here. In order to get there, I start with my starting value, which is -3, and then I subtract 4 times, which is what we have. I'll use the yellow to illustrate this. Actually, let's use the green. That's what I have here. I have -4 multiplied 4 times. -4 multiplied 4 times. That's the connection here. Let's see if we can work it out in the opposite direction. Let's say that I have a sequence that is given to me not as a formula, or not as an equation, but actually as the list of numbers. And so let's say we have 12, 14.5, 17, and then 19.5, and so on. So this is my sequence of numbers. Let me make that a little more clear. This is my sequence of numbers, and I want to write a formula in the explicit form that represents this sequence of numbers. And so again, that's going to be a sub n. A sub n, so some particular number in the sequence, is equal to my starting value. So my starting value is 12. That's what I start with. So I have my starting value of 12. And then I'm going to be, let's see, it looks like I'm adding at each step here. And what am I adding? Let's see, to go from 12 to 14.5, I'm going to add 2.5. And then similarly, to go from 14.5 to 17, I have to add 2.5. And then to go from 17 to 19.5, I have to add 2.5. So my common difference is 2.5. So I have plus 2.5 here. And then I put multiplied by n subtract 1. Let's see, what column am I doing here? White, yeah. Multiplied by n subtract 1. So this equation defines any number in my sequence here. If I wanted to know what n1 was equal to, remember that n1 is if I wanted to know what a1 was equal to, that's this number right here, then I would just substitute in a 1 for my n. If I wanted to know what my a2 value was, I would substitute in a 2. If I wanted to know what a3 was, then I would substitute in a 3 for n, and so on. Let's say I wanted to know what a11 was equal to, a sub 11. And so we have, let's see, 12. I'm just going to copy this equation here, but I'm going to replace n with 11. So we have 12 plus 2.5 multiplied by 11 subtract 1. Remember, I'm just replacing n with 11 here. Then I simplify on the right-hand side. We have 12 plus 2.5, and then 11 subtract 1 is 10. And then I continue my simplification here. 12 plus 2.5. Actually, let's take a step back. That's 12 plus 2.5 times 10 is 25. And then 12 plus 25 is equal to 37. So a sub 11 is equal to 37 based on this sequence right here. So three examples here of using the explicit form of an arithmetic sequence. And two of these, we started with the equation itself and worked out the sequence, the values for the sequence. And then in this one, we started with the values for the sequence itself and then worked out an equation. One final thing that I want to point out here, which I will do in red, is that sometimes instead of seeing a sub n, you will see a of n written in function notation like this. These mean the same thing. This is the nth number in the sequence. This is the nth number in the sequence. They mean the same thing. Similarly, you might come across something like this, which means n subtract a sub n subtract 1, and that would just be the same as a of n subtract 1. In other words, the previous step in the sequence, the step or the number immediately before the nth number in the sequence. So these are arithmetic sequences in explicit form, and in the next video we'll look at arithmetic sequences in what we call recursive form.